In this example, we want to find the derivative of this kind of messy looking quotient. The top is x squared and the bottom is the fifth root of x squared. And so we could just go through and tackle this using the quotient rule, but that's far messier than it really has to be, because both the top and the bottom are simple, are very simple. There's no plus sign or minus sign on either one of them, and in fact, each one is actually a power of x. And so the top is clearly a power of x there, x squared. But this fifth root of x squared, the fact that we have the fifth root is telling me that my power of x is 2 from the fact that it's x squared under the fifth root, but then over 5 because of the fifth root. So we're looking at x squared on the top over x to the 2/5 on the bottom. And we'd really need to at least do that rewriting before we tackle the derivative just to handle the root. But now take a look at what we have. We have a power of x on the top divided by a power of x on the bottom. And our exponent rules say, since the bases match, take that base and have the exponent from the top, and then from it subtract the exponent from the bottom. So what we're looking at is x to the 2 minus 2 over 5. So combining that, doing that arithmetic there, 2 is really 10 over 5. So we're looking at 10 over 5 minus 2 over 5, which would be a total of 8 over 5. Now, I've done a fair amount of work at this point, but I do not have the derivative even started. All of this work that I've done is algebra. All of those equal signs make sense because they're all equal to f of x through algebra. But now we're ready for the derivative. So we have f prime of x is equal to what we would get when we utilize the power rule, because this is just an x to a constant. And so what we do for the power rule is we bring down that power, and that power is a little messier than just your typical integers or even positive integers, but it's still the power just the same. And so we bring that power down front, and what we have is the new power would be 1 less than the old power. So our old power was 8 over 5, and from it we need to subtract 1. Now I'm going to go ahead and write that 1 in a fancy sort of way so that I have a common denominator. I'm going to write 1 as 5 over 5. And so when I go to clean this up, I've got that constant 8/5 that's sitting in front, and the power on the x is going to be 8 over 5 minus 5 over 5. So that would just be your 8 minus 5, which is 3, over the common denominator 5. And that would be the answer for our derivative.